For seismic load generation, the risk category shown in the results can be changed here in the site information. The structure type presented in the results can be changed here, where there are three possible options. By default, when neither boxes are checked, the structure is assumed as a regular structure and the following clause of ASC 7 is implemented. This clause states that for a regular structure 5 stories or less above the base as defined in section 11.2 and with a period t of 0.5 second or less, CS is permitted to be calculated using a value of 1.5 for SS. What this means is that if the designer enters a value of 2 for the short period for a regular structure, the maximum value that will be used in the determination of the base shear is 1.5. Let's verify this in the log file. Enter a value of 2 for SS, delete the loads, and regenerate them, and then rerun the design. Select the log file, scroll down to the table of calculation of total design base shear, and look at the SS value. The value used is 1.5. Now let's verify this if the structure is irregular, that is, if one of the two boxes is selected. Delete the loads and rerun the design. Select the log file, scroll down to the table calculation of the base shear. As it is possible to see, the value used is now 2. Since the program does not detect irregularities as the Canadian version, it is important for the user to verify if the structure has irregularities and to notify the program by selecting one of the two irregularity options. If the horizontal irregularity or in-plane vertical discontinuity irregularity is selected, then the drag strut forces are increased by 25% according to the following clause. The program will use the worst case of the forces derived from the 25% increase of diaphragm forces and the shear forces to calculate drag strut forces along the shear line. Note that the force from the 25% increase will generally govern only on the top level of the structure, and in some cases on the level immediately below. For example, considering this 5-story structure with the following geometry and site information, we will now generate the loads and run the design. Now, to see the drag strut forces when the structure is considered as a regular structure, we'll go to Table, Seismic Design, Flexible Diaphragm Design, and Drag Strut Forces. Looking at Level 5, Opening 1 on Line 1, we can see that the drag strut force is found to be the following. Now, if we select the horizontal irregularity or in-plane vertical discontinuity irregularity, we will now delete all the loads, regenerate them, and rerun the design. Looking at the same drag strut force on level 5 for line 1, we can now see that the new drag strut force represents a 25% increase. Although the program does not detect irregularities automatically, if either of the option is selected, the structure is considered as irregular for redundancy purposes. It implements the latest clause regarding the redundancy factor rho. Rho is a reliability coefficient that penalizes structures that are less redundant by increasing the horizontal design forces by 30%. New in Shearwalls version 10 is the option to use the calculated redundancy factor, the value of 1 or 1.3. If the selected option is calculated, then for the initial design pass, rho is set to 1, and after design it is calculated, and if it is found to be 1.3, then the design is redone using that value. This is done independently for both directions. Refer to the building code for definitions of regular and irregular structures, as well as the ASCE 7 standard for more information. The design category, also known as the seismic design category, presented here in the results, is dependent upon the risk category of the building, site class, as well as the short and 1 second period response acceleration parameters with respect to the following tables from ASCE 7. The risk category is based on the use and occupancy of the building or the structure determined in the following table in ASCE 7. The short period response acceleration parameter is dependent upon the site foundation factor Fa and of the 0.2 second map acceleration parameter Ss, which relationships are described by the following equations. The foundation factor Fa itself is dependent on the site class and the 0.2 second map spectral acceleration parameter Ss, and can be determined using the following table of ASCE 7. On the other hand, the 1 second response acceleration parameter is dependent on the site foundation factor Fv and the 1 second map acceleration parameter, which can be determined using these equations. The foundation factor Fv itself is dependent on the site class and the 1 second map spectral acceleration parameter S1 and can be determined using the following table of ASCE 7. Found in the results are the risk category, design category, site class, and spectral acceleration for short period and 1 second period, which can all be modified in the site information. In Shearwalls 10, the seismic design category is updated automatically as the input changes compared to before, where the seismic design category was only known once the design was completed. The fundamental period used will differ in the output results if in the site information the use calculated approximate period is deactivated, thus allowing to enter custom values. The response modification factor R used in the analysis is calculated automatically based on the materials used in the analysis and can be seen and changed here in the site information. The values can be seen for a bearing wall system and a building frame system. Finally, The foundation factors are dependent of the site class used, which can be seen in the Site Information tab. This concludes this first tutorial of this series. The next tutorial will cover the structural data and the loads generated.